Survey result. First, I want to thank all who had already answered to my survey. This is not the aim from this survey, not the same like the survey that you will maybe by the end of each semester you will receive a survey that about evaluation, maybe for the instructor or the ecosystem in the whole. How was the lectures and the whole material being delivered? The aim from this survey, since we make a software analysis and design, and we believe that the customer feedback or the client, we are a team, but whatever, there is a service is being delivered to you. So rather than waiting till the end of the semester and see what it was your opinion, so we need to discuss now to see, are we on good track? Do you have some suggestion? By the way, I got many nice suggestions, maybe from your sections, from other sections. It was really give me some ideas to do some improvement in different places. So I want to thank all who have already participated in this survey, and I will keep it open. So anyone who hasn't participated yet and he want to participate, go ahead and participate. However, I will open now the result for you who are now and for the others who will watch this recorded video, made to discuss what the result we will have. And I will answer the questions for some comment. Maybe some people have already have some comments here. So let me first share. SharePoint. I'm just logging in. Here we are, the forms, CIS. I should be very transparent with you, so I will share you all the response that I got it so far from your class. Here it is. I will go to responses. So there are 14 students that have already participated in this survey, and this is perfect. And as I said, I will keep it open, so who will more want to give us his feedback or an opinion, go ahead and do it. It will be anonymous. So as you see that I will not know, I don't know who has applied, but I know that you are from this class. So concerning how clear is the course materials explained, we have 7 said extremely clear, 7 very clear. This is perfect. I'm very satisfied with this result. Have the instruction material delivered so far increased your knowledge and skills in the subject matter? 6 strongly agree, 7. So perfect, 1 neutral. Did the course give the confidence to do more advanced work? Neutral and 9. So we have almost 70% agree and strong agree, and maybe who said neutral, because we still have only 1 assignment. This is why I will accelerate more the rhythm of the assignment. Today, I will deliver the second one, and I believe when we start the project, we can apply the whole concept that we have learned in this project, because it will be a real case scenario. We are going to develop a project from A to Z. So I think in this case, you will be more confident about how you will apply what you are going to learn in this course, or to let you more go ahead and dig more about applying what we learned so far. How helpful was the homework assignment for understanding? Somehow helpful, extremely 6, so almost 70%. This is perfect. We don't have not so helpful, so we don't have negative reply, we have somehow somewhat helpful. And I think that, again, with having the more assignment, it will help more. How well your question are answered during the live session via email? Very well, extremely well, somewhat well, perfect. It seems that also we are going the good track. The speed of the course, 12 said we are in the right amount, 1 is too fast, and 1 much too fast. So I think maybe in the first or the second lecture we were this, but I will consider this feedback also, which means that I will not have very long lecture from now till the end of this course. So in order to be always on the right track with the right amount. Therefore, during creating a good learning atmosphere, 8, 5, so 8 very good, perfect, 5 good, so 8 plus 5 you have 13 out of 14, 1 set fair. Maybe who said fair now in the comment, we can see some comment, so we can understand more why he said fair. Are you attending live session? 5 yes, 5 who didn't reply said no, and this is good that, to be honest, the main aim from this survey, I would encourage who didn't attend live session to be more interactive with us. So no sense. So just one said that he can be available, but he prefer that to watch it at home. Again, I said it is very highly recommended that if you have time to join us in the live session, because you can ask me directly questions and we can have some exercises. This interaction will let you understand better rather than go ahead and watching it, because I know for myself, when I go to online courses, sometimes I will get bored watching 2-3 hours video. So however, having a live session more interactive, it will be easier to me to understand. I think most of us like this. So who can go ahead to the live session in this case. Had the class time well used? Extremely yes, 7. So 6, so perfect, somewhat. So most of the reply here also, organization. Let's go ahead and see about the suggestion. Anonymous, he or she, I don't have any suggestion. I found the way this course being taught to be perfect. Good. Anonymous said, Ismail is very encouraging professor. I can't think of any improvement. He can, I think maybe some how to work on outside of the class would be helpful. Okay. Yeah, this is why I said today we'll have our assignment too. Meeting time should be mandatory for this course. I agree. However, according to the policy of the university, it is an asynchronous course, even though we don't expect to have a live session. I did a live session. It is an optional because the mode of teaching of this course is asynchronous rather than recording video, but to myself. So I said it's better doing recording the videos, having other interacting with me during recording. You can participate from time to time, help us. We may have problem during live session. Okay, perfect. So when we are break down to different rooms, having this group work, normally I will say that I will be with the chatting. I can see your chatting. If you should know that when we be in the group work, I can see the chatting while you're talking with each other. So as always said, when you need me, just type something that please join us. However, based on this command, I will interfere more in the rooms. But I believe that I want to give you more space that to do it alone. And if you want something to ask me, because I believe that students, if they have their instructor with them, sometimes having the instructing with a student, they are working, somehow it will let them home somehow confused. So in order not to have this, however, I will consider this command. I will interfere more in the rooms while during the group work. Add subtitles. Subtitles already generated. To all of you that when I upload it to YouTube, the video, I will make the language setting, which is English 1 or English settings in this case. So you can go directly, there is a sign with CC, something like this. You can activate it from your side, and then the subtitles will be automatically generated. So it's already being done. Who wants the subtitles? just he has to activate the button in the YouTube. The YouTube will automatically generate them. No improvement is needed. Everything is going so well. Okay, perfect. That's so nice. I want to share you the result because I think that who wrote this command, I don't know who wrote this command, so I have to reply to them. This is why I share it here during the live session. Anyone, before we start the lecture today, anyone who's here want to discuss more anything concerning this survey or have any idea, I can hear him before we start. If not, I need 3 thumbs up to continue the lecture. 3. Perfect, perfect. Okay. So the last time we have already talked about in the last slide about requirement. No, this is maybe, yeah, last time we talked more about ER diagram. This was with the lecture before, it was here by mistake. Last time we talked about the ER diagram, if you remember this, and how we create an entity relation diagram. Was the last step in analysis, according to the life cycle that we are working in it. So after we finish the planning, we go to the analysis. In the analysis, there's 2 parts, requirement determination and requirement structuring. In the structuring, there was 2 parts. One of the part was concerning requirement, the use cases one, how we make a graphical modeling for the requirement, and the other one was about the data modeling, which is we are going to focus more now during the other parts in the cycles. And the data modeling, the requirement that we have already collected based on the use cases that we have it on our project, we agreed what different entity that we need to store data about it, that will have different parameters that we need to store them. And we created something, the last structure, named entity relational diagram, which is to understand more what is the entity we will have in our database and what is the relationship between them. And this is entity relational diagram that we have already discussed the last time. It gives us an image about what expected data containers, or let's say now we start telling them tables. At that time, we don't use the word table, we use more the word entity, because it's more an upper level design, upper level analysis is a sketch. So we don't have a real tables to say that we start have a tables. Today we will talk more about this database design process, and we will talk how we can transform this ER diagram to a good relational database schema, which is a pre-step before we go and make the implementation and creating the physical tables or the physical files. And again, we should make something normalization. Normalization, it seems that it is the enhancement of the structure that you have already done, because sometimes you create your own design at you and based on analysis that you have already done it, and then while you are inserting because the database later we are going to insert data or select data or delete data or update data. So what will happen that based on the process of inserting, selecting, deleting, or updating, you find sometimes that your design was not so much correct. It's like when you build a house and said, okay, after you imagine the house how it would be, you make the sketch, and then said when you get the furniture and put it in, okay, this room should not be here, it should be there. Yeah, now this is not easy to do it. It's like here. So in this case, you are going to make a renormalization, the enhancement of the structure. And then today we are going to learn, after we got this logic design, which is a pre-step before we go to write the code and create the table size. So still we can to discuss the normalization to see, is this structure a well-structured? Yes, no. So this is when we talk about database. If you remember that we finish, so far, as I said, we finished here, planning, it's done. Analysis done. Here, the delivery from here, we have an ER diagram, as I said so far. Today, we will start with a design. And we are going to start with the design of the database itself. So how we translate this and how we are going to get our structure. This is from the old lecture. You should keep it in your mind that how will be the data modeling or the database modeling and implementation will be, how will be, let's say, what will be the final deliverable of this database structure and designing after each one of the cycles. So after analysis, we got the ER. Today, we will talk about the logical data model, the relational database schema. We should have something like this, that the name of the table that should be somehow the same name in the database later, and what attribute it have, and what is the types of this attribute. So it is another schema. The first one, it was the ER was only such kind of sketch. However, from this design phase, we expect to have this logical data model. Based on this, you are going later to make coding. Something I told about the last time there, something we name it, for example, in SQL, DDL, Data Definition Language Queries. There's two types from the queries. To create a database, we go to DDL. So we'll start with writing the code based in the platform that we use it. So if you are going to use a database management system that is compatible with SQL, like Microsoft Server or MySQL, whatever, any kind of database management system, so you have to pick the programming language that is compatible with this platform, and based on this schema, you are going to create the physical files for your database. This will happen with implementation. And later we are going to make always data model evaluation and maintenance based on what. So here we are. So we should have the logical data model and physical file database design after this phase. Let's start. ER diagram. Maybe you have now a question in your mind. So, okay, we have ER diagram. So we can take, so we know how many tables we have. We can go directly to implementation. Why you are going to make something, you name it here, the relation database schema, where a new schema you have to do. Why don't take the ER diagram and go to implementation? Anyone have an answer for this question? Any volunteer can give an answer? I repeat my question. If you don't have an answer, no worry, I will answer. My question is that now we are going to transfer this ER diagram to a database relational schema. And then we will take this database relational schema and we write a code and create the physical files. Why we should have this middle schema between ER and the physical files? Why we didn't take the ER and go and write the code and create the physical file? Why? Anyone has an answer? I will give you the answer in this case. The point that ER, tell me about the tables that I have, the main tables that I will have it, plus the relationship between tables, if you remember, like many to many, one to many, exact one-to-one, optional many, whatever it is, what we have already discussed before. However, maybe there are another artificial tables I have to create from these relationships. This is the first point. Another point, the relationship that I have already mentioned in the ER diagram. I'm not talking about, sometimes the entity in ER diagram, we name it a relation. because it is a relation between set of attributes talking about the same concept. Don't be confused between the relation and the relationship. So an entity or a relation is talk about like customer, like billing, invoice, supplier. Good. It has set of attributes. However, supplier give an order for a stock that table or an entity. So this relationship, when we will go to implementation, what will be? Why we made this relationship? So in ER diagram, we mentioned the main entity and the relationship, but we didn't tell how this relationship is going to be, what we are going to deal with it when we go to the implementation. So this is the main aim. Here we have to go to study the relationship. How will this relationship, it will be now this relationship, we will have something we name foreign key and a primary key to make this relationship. So we have to deal with this relationship because maybe we'll create a new artificial table for this relationship, or we have to transfer some attribute from table to another table. This is why we should be aware about the relation, about not to go direct from ER to the implementation to do this database schema. So in ER diagram, we will have a main entity. So the first step will be that this is ER diagram, and this ER for each entity. We don't now forget the relationship. For each entity, we will create a table, not we will go implementation. We will create a table, which means that customer name, and make, for example, we will like this, do it, which is, we said, okay, this is, and we have a table name, because we expect that for each entity, we will have a physical table later. So we start with the all entities, ignoring all the relationship, and we mention them for each one a table in this relation database scheme. This is first step. Now we have to go to the entity relationship. The relationship, we have either one-to-one or one-to-many, or we have many-to-many. I'm not talking about exact one or one. It somehow doesn't differ so much in the when we go to the physical files. So if I'll have like here S and T, I'll have, for example, here an S table, and I have a T table or a T entity. I'm talking about ER diagram. And now they have a relationship one-to-one. Whatever the relationship it is. Suppose it is, I name it R, whatever. And then we'll have here one-to-one. So according to the first step, I have to create a table for S in the schema, and then table for T. Suppose S has 3 attributes. It has X, Y, Z. And T has 3 attributes. It has A, B, C. Here, X is the primary key. We talked about key the last time. X is a primary key here, according to the entity relation diagram. And in T, A is a primary key. So now, we said that they have one-to-one relationship. So one-to-one relationship, what will affect, what is going to affect now this one-to-one relationship, my database schema? How I can say that these two tables I'm going to create a new table that is going to join them? No. So we will not create a new relation for this relationship. So we have 2 options. Because this table, they have a relationship. When they have a relationship, so, and an attribute from one of them we should have a copy for it in the other one. If we will have a one-to-one, either the primary key of S, we can put a copy from it in T, we name it foreign key, or the primary key of T, we can put it in S as a foreign key. Both are correct because we have one-to-one relationship. So I can do it like this. So I will come here, go here, I put here A. By the way, I can give it another name, but when I will write the code later, I will say I write in the code my foreign key. This is, we said, referential integrity. I will say, okay, this is A is a foreign key from table T. I will have this. There is a special code later, but here in this is why in the schema now as if S it has 4 attributes, not 3 attributes. So S will have X, Y, Z. In the schema, I will mention here that this underline because it's primary. It is not the primary. It is a foreign key. Again, not a primary, a foreign key. What is a foreign key? A foreign key is a primary key for another table. We put a copy from it in this table because to have this relationship between them. So in this case, as if they are related. So each row from here, it will have an A value that come from here. So as if I make this relationship in the design of this table. It's very important you understand this, that the relationship in one-to-one, I don't create a table for it. I just move. It's not move. It's I will make a copy from one of the primary key, if one of these 2 tables, and put it in the other table. Like here, so the final we will have X, Y, Z, A. T, we will have A, B, C. A as an A is a foreign key. So, and this is primary. So now, whenever I will insert any new value on S, they should have the corresponding value from A, from TA. So now each row of S, it has a corresponding value from A attribute. So when I said A attribute is a primary key, which means it is this primary key, it is unique. So now I have this relationship between these 2 tables in this case. Is it clear? If you have a question, go ahead and ask me. If not, give me 2 thumbs up to continue. So I have only one. Shane.
I have a question.
Go ahead.
Yeah, so basically you're saying that if it's a one-to-one relation, you don't need to like create a table or anything, you just add the foreign key?
Yeah, we don't need to create a table for the relationship, but we create 2 tables for the two main entities. You got it?
Yeah, I got it.
So what was your question, Shane? Or Sahib who's asking?
Oh, it was me. Basically my question was if do we need to make like the 2 tables if it's a one-to-one?
Yeah, because what so far we have already discussed that this is sequential. So at the beginning, you go and create table for all entities without the relationship. Next, you will start seeing the relationship. So the table S and T we have already mentioned in the schema.
Okay.
Based on the first step that we have already. Now we are on the second step.
Okay. Yeah, I understand.
Perfect. Let's go now to one-to-one relationship. Now I put an example in the first slide. I don't want to put example. I want to sketch it with you. So here we have a one-to-one, one-to-many relationship. Here one, and here many. Again, we will create, based on the first step, we will create a table for customer and we will create a table for order. Forgot, at the beginning, we will not mention here this. So according to the first step, we will create a table for the customer and a table for the order. And we will mention the primary key of each table. Customer has a customer ID, has name, address, city, discount. Order has an order number, order date, and promise date. So we have 3 attributes, and there we will have 5 attributes. Now we will go to the relationship after we create a table for the main entity. If you go to the relationship, I said it is not one-to-one. If it is one-to-one, as we did before, so we can just put either the primary key here, put it as a foreign key, or the primary key here, put it as a foreign key. However, when we have a one-to-many, we have to go and put the primary key of the one in the many side, in this case. So we put the one in the many because we believe that this one key, which means that when we said one-to-many, we believe that this one is going to have related to different rows in the other one in this case. So this is why we put the customer ID here. And again, this is not a primary key. This is still the primary key is order number. This is a primary key. And here, this is a primary key. Just this is here, it is a foreign key. So now each row from this table will have the corresponding ID or customer ID. What about now many-to-many relationship? So we said from the beginning we have 3 types of relationship, either one-to-one, or one-to-many, or many-to-many. And sometimes many-to-many relationship, we will have an attribute related to the relationship. We have already discussed this before. Like here. So here we have a product and we have order. And for the product, I said, okay, we have product ID, description, room, whatever city, so on the other it have one. So now, according to the steps that we did, at the first step, we will create a table for each entity. Sorry, this is a product would be here, and the order would be here. So we create a table for each one of them. We are done from this. Next step, what will be? Next step will be that after we have creating these tables for both of them, we have to go to the relationship. Many-to-many, then we are going to create, this is what I said, Sahib, that when we will have many-to-many, we are going to create a table for the relationship itself. Before this, we just move a copy from the primary key to another table, either from one-to-many or when you will have one-to-one, one of them to the other one. However, here, we can't do this because each one will relate to many and each one from here related to many. So we can go ahead and set that each record will be related to one from the other side, so we can get the foreign key and put it here. This is why we need a table for the relationship. So we created a table, and in this table, we will get the primary key of both of them and add it here. The two primary keys from the two tables will form the primary key of the new artificial table. I name it artificial because we don't have this before in the ER diagram. We created now when we did this schema. So the order line will have the order number here, and we will have the product ID here. Both of them will make the primary, both of them will make the primary key for this table. And if this relationship has any attribute, we can add it to this new table that we have already created it. So I will repeat it to the last time. So when we will have a many-to-many relationship, like always, we have to go to the entity, and we will create for this entity, for each one of them, we create a table. Done. To the relationship, we'll create a new table for the relationship. The primary key for this table will be a composite primary key that is included the two primary keys from the two tables that it related to, plus any additional attribute that is related to this relationship. Sometimes there will be no here, so nothing to add it here. It will be a table with only two attributes in this case. So now, based on what we have already done, so we can create the schema that we needed. Perfect. But the schema that we have already done it here, order, product, blah, 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 we didn't mention what is the type of the attribute. We should mention here. Now, choosing the type of the attribute somehow depends about the expected platform that you are going to use it. Oracle, MySQL. So because in each platform, they have a defined types that you have to consider. Most of them, they are most similar, which means they're having this var char, long number date, binary large object. So, and sure, they have integer. This is from the Oracle one. So you just here in the schema, here after do this, for example, like here, I said, okay, this order number, I will not, by the way, when we make the schema, I just here, we mention here the values to see how the values, to visualize how this AR diagram will be done in the schema. However, the schema is like this. This is the schema. You mention the type, the name, and then with each name, you're going to mention the type, like custom ID, you put 2 points, and you said, okay, this is integer, this is var char. So you have to do this in the relation when you are going to describe this relation, to add this attribute types to this. I name this, in the book they name it logical data model. I name it more relational database schema. Both attributes are correct. The book uses that we are using logical data model. Me, I will prefer to use relational database schema. In the work environment, when you go to the real life working, so most probably they will use relational database schema. Why we use our word relational? I said it before that database structure has different design. One of them, the most used, is relational database schema, especially when you are talking about information system projects that they are more oriented to business-wise. Like here, making a AR diagram for ERP system. However, if you are dealing with, maybe you need a real-time database, like a database for location. If you work with Android, so they will use a Firebase database. It is not a relational database, it's structured database. Some there is database, no SQL database, we name it. So there are different types of database. The database that we are considering in this course, because this course is more oriented about business information system for business application. based on the planning that we did it before and the analysis and all the stuff. So more they are relational database. The word relational comes from two aspects. First, that the table itself, it is an entity, we name it relation because it is a relation between different attributes talking about the same concept. Like here, customer ID, name, address, they are talking about the customer. And they have a relationship between all tables. This is why we name it a relational database structure. And here we can set logical data model, this one, or it's more well-known using relational database schema. So if I use a relational database schema or use a book abbreviation logical data model, both are correct in this case. Okay, let's do an example exercise and I will do it with you. I don't have the solution here, I just put it here. There are still parts in this course, however, the aim now is we have finished about how we came to the relational schema. The other part about how we make normalization. Before I go to normalization, let's practice an exercise with each other. So I will break you down if you want to 2 rooms like always, or we can do it here with each other. I prefer that break you down to let you discuss it with each other. But first, let's talk about the exercise, what we need from this exercise. The exercise is asking us that to have a database to manage doctor and patient. Suppose we have a clinic. But we should be stuck to the requirement here. Don't think about the whole requirement. I'm asking you the requirement to this use cases. A patient is followed by a unique doctor. So a patient is followed by a unique doctor. A patient is identified by his name. Again, a patient is followed by a unique doctor, which means that sometimes I don't think here in Canada they have this restriction. Yes, no, I don't think so. No, they don't have this restriction. We have something in a family medicine doctor, but you can't go house to another work in a clinic. But in some places or some cities, they will somehow, you should go to your registered family clinic doctor and before you go to another one. It depends. So each patient followed by a unique doctor. Each patient has only one family medicine doctor, a unique doctor. A patient is identified by his name, his ID, and date of birth. So there is 3 attributes. However, this ID they are assigned by the doctor, and different doctor may assign the same ID to the same different patient. Listen to this. The ID that they are unique to this patient, they are not somehow, let's say, it's not like the health insurance number that all of us have it here, that the Minister of Health will give it to us. No, they, according to this use case, each doctor will give you an ID, and you will have an ID. So if I am Ismail, go to a Dr. X, so I have ID 1 given by X. Sahib, go to another Dr. Y, and Y maybe give him also 1. However, if I said 1X, it will be unique because the same doctor will not give the same 2 ID to the same patients that come to him. So this ID, it is not a global unique, it is somehow unique by the doctor itself, but however, 2 different doctors can give the same ID for 2 different patients. This is somehow tricky. This is the aim from this question. So now each doctor has a name, has a specification, has a unique ID assigned by Minister of Health. So all doctors has a unique ID that the Minister of Health is giving them. Do you have any question before we go to start? We need to have an ER diagram for this, and then we are going to transfer this ER diagram to the relational database schema. There's 2 steps we have to do it now. So Can we go to break us 2 rooms? Are you okay? And then we are going to return to the main room. When we return to the main room, we will discuss the solution and continue with the lecture. Are you okay with this? I need 3 thumbs up. 3. Perfect. Okay, let me break you down to rooms and see you in the rooms then. Yeah, let me delete this room. Delete this also. Automatically assign rooms to them. Hi. Yeah, I saw that you are now here. I will, yeah, maybe I can do it now. Reassign you.
Yes. Hello. Sorry. I think it's fixed now. I
Okay,
downloaded
perfect.
the app and now it works.
Yeah, but do you know which room you were? 1 or 2? I think
With
you.
Kevin and Pardenit.
Kevin? Okay.
Yeah.
Both of you, yeah?
Yeah.
Shane. But it tell me that I can't assign as if, because you can go to the main room because you are already assigned there. I can reassign you. You have to join it from your side.
Join it from.
You already still in the main in the room 1. However, you left the room 1 to the main room. So you can do it again and go to the main room. I try to assign you, but you have already been assigned there. So I can't reassign you. You get my point?
Yeah. It says that I can request to go into the other room, but that's not the one that I want to go to.
No, go ahead in room 1. You can rejoin. You can go ahead and rejoin the room itself. We have Kevin here also now. What's up?
I don't know. Reese just invited me here.
Okay, see, but you can do it. I can assign, but I can't enforce you to join a room. You get my point?
Yeah.
What I can do in this case, just I can close the room and then reopen it in this case.
Okay.
Then you will be here, and then you can go there again. I can see this like this. I will do this. So closing the room. I think that more 2 person will be here now. Yeah, I think now I can, but it's still closing. Kevin is still there in the meeting. What's up?
We're all here now.
Yeah, but it's from my side, it's still saying that, yeah, now it's closed. I can now open the room. Maybe you can rejoin there in this case all. Say it's opening, so yeah, it worked. Man,
It didn't move us.
do you receive something from my side? Ask to join. The person is not here. That said, assign now.
Yeah, I'll try to leave and join back. Maybe.
No. Wait. Because maybe I make for Shane guest. I have to say. Okay. Maybe when I assigned you, because I can still see your name as a guest and your name as a member.
Oh.
I think now I can do it. Wait, let me double check here. So assign. Shane is assigned, unassigned. Race is unassigned. Assigned to room 1. I think now it will work. Yeah, you will move there.
Oh, there we go. Okay, I think we got most of it done too. So.
Perfect. Yeah, because also we should return here. Hi guys. How are you?
I'm good.
We're good.
Okay, who will share with us the solution for this before we complete with the lecture? Let's start from room one. Who will be the volunteer from room one? Who will be from room one was going to present?
I think Kevin has it saved.
Okay. Kevin,
Let me
are you
just
okay?
download the picture real quick and should be good. Sorry, one sec.
Take your time.
No, okay. Was it whiteboard or
Yeah, whiteboard.
you want me to draw it?
No, it's okay. Whatever. Do you have it as an image or still you have it in the whiteboard? So
The image you saved, you can just share that, Kevin.
Okay. Okay, you guys see it?
Yep.
Okay, so
yeah.
basically we have two entity, one patient and one doctor. And then there would
Okay.
be, so each patient would have only one doctor and it's mandatory. And then each doctor can have multiple patients. And the attribute for doctor would be doctor ID for the primary keys, name, they can be last name, specification. And then patient would be patient ID, name can be last name or first name, and then birthday. So the reason why we put doctor ID in here because as you said in your assignment, IDs are signed
Okay.
by doctor. And yeah.
Okay. Now, when we talk about ER diagram, we don't have to make to somehow to mix between ER diagram and the relational database schema, which is the second step that we have to do it. What we have already discussed today. ER diagram talk about each entity, each relation, what has diagrams, and what is the relationship with the other entity. So doctor ID, it is not an attribute for the patient. You need it. You need it. I know this. But it is not an attribute from the entity, from the patient. The patient has a patient ID, has name, has birth of date. So in the ER diagram, we have to tell each entity what is the own attributes or characteristics, and what is the relationships. In your relationship, you said one to many. I agree. However, the patient itself, the problem that if we will leave the patient ID, it cannot be as standing alone as an ID. because we said it is not unique. It is related to the ID that will be given by the doctor. Yeah?
Yeah.
So in this case, patient, it is a weak entity. In the lecture, I said that we will have two types of entities. We have a strong entity, which is normal entity, and we will have some special cases, special entities, we name it weak. I give the example of player and team.
Mhm.
And I said that we have to avoid as much as we can using weak entity. And in some cases, if we can't create an ID, go ahead and make an artificial one. If not, then you have to make it weak. So in this case, we can make it weak. You know how to make a weak? You have to make it double line. The border will be double line in this case. And don't include the doctor ID. Just put the patient ID, because automatically when it is weak, which means that it's going to use the ID from the other table that had a relationship with it. So here, patient is weak. Why weak? Because it has three attributes. No one of them can be a primary key. And it needs another attribute from another table that has a relationship with to create its own composite key. So it would be two, the patient ID and the doctor ID. As ER diagram, we talk about each entity, what has characteristics and what it has relationship. What you when we transfer this to an relational database schema or logic data model, in this case we will make a table patient. We will put in this table patient ID, doctor ID, and date of birth and name, and doctor will put doctor ID and name, and we put specific and specialization or specification in this case. Do you get my point?
Yeah, I got it. But
What
then,
about the other?
so in this case, we just let it be. So the patient would be a weak entity, right?
Yeah,
It's nothing we
and
can
in
do
this
about it.
case, we don't have to add a doctor ID, because automatically, if it is a weak, which means that it will use a primary key of the other table in this case.
Okay, then the patient would be a double line, a border, right?
Yeah.
Okay,
Yeah.
got it.
But now, what about the room 2?
Okay, I'm just gonna stop sharing screen real quick for you
Yeah, stop
guys.
sharing, please. Who is going from room 2 to volunteer to let us see the solution? No, me?
Yeah, me.
Go ahead.
Okay, I'll share my screen.
Yeah, don't forget, we still have a part in the lecture we are going to discuss after this.
Okay, can you see it?
No, go ahead.
Can you see my screen?
We can see your screen.
Okay. We created like this ER diagram to show like each attribute of the patient.
Did you consider, did you have considered that, yeah, maybe your colleague want to tell something? Mitash, do you have to add something?
Sir, screen is not visible.
Sorry?
The screen is not visible.
Oh.
Even I can't see the screen.
I can see on the screen. Now. No, Mia, now we can see your screen. No.
Yeah.
You can see it?
Yeah.
Okay.
I can see myself. Okay.
Can you see the diagram? Can you see the diagram?
Yeah, but we don't, according to the low one, we don't use this abbreviation. We use the one in the upper side.
This one?
This is a standard that we use it in our course, yeah. Because the down, this is another standard that the lower, yeah, this one.
Okay. We
So
tried to show that like a doctor can assign like the same ID to multiple patients. Yeah.
yeah, so it is the same scenario like the group one. So you didn't consider the doctor as a weak entity.
Oh, which is
Sorry, the patient as a weak entity.
oh, yeah.
We said that since the patient has 3 main attributes, one of them the ID and name and date of birth, and we can't create a primary key from these attributes. This is why we said that we need an attribute from the other table to create the key for the patient. So the patient will be weak entity in this case.
Mm.
And when we will transfer it to schema, the patient will have a patient ID, doctor ID, patient name, date of birth. Doctor will have a doctor ID, doctor name, and specification. Why in the ER diagram we have to say this is weak? How we can say it is a weak? Make a double line border for the patient entity. Are you okay, Numi?
Yeah. Okay. Yeah.
By the way, I just want to put or mention this exercise here because I know that the weak entity, many of us, we will not see it in many times. So I thought it is a special case. And when we will make a design for a database, we have to avoid using it. But in our case, we can't create a patient ID. And according to the requirement doesn't tell us that the Minister of Health will give a unique ID. The requirement said that this ID will be given by a doctor. So based on this, we have to do it in the way we have already done it now, using weak entity. So are you okay all with this? Can I continue? I need 2 thumbs up to continue. Perfect. Okay. So the last part that we are going to discuss today is about data normalization, database normalization. So far, what we have done so far that we have the schema. We know now. We did the ER diagram, we did the schema or the logic data model, or we name it relation data schema, both the same abbreviation. Either we said relational database schema or logic data model, both of them. Based on both of them, what we have already done so far that we have the tables and know what is the foreign key and the primary key, because we said there is a foreign key and a primary key. And we start dealing with this database. We insert data in this database and we start select. However, we find that this structure has some anomalies, redundancy. Why? Let's see. And we have to restructure it, or we have to make a renormalization or normalization for the existing structure that we have already built. So, but before I start, there is a concept, we name it functional dependencies. What is a functional dependency? So far, we have already discussed the relationship between tables itself. Table A, relationship with table B. However, we didn't discuss about the relationship within the attribute themselves in the same table or in the same entity. So you will find that, okay, we study the relationship between tables to show, because after this studying the relationship between tables, we can know that this attribute, we can move it, copy it from this attribute, because this is one-to-many relationship, or because we have a many-to-many relationship, we have already created a relationship for this two different attributes. However, to know that this structure is coherent, there is no redundancy, all attributes are talking about the same concepts, we have to study the relationship between the attributes themselves in the same table. This is what we mean by functional dependencies. So functional dependency, it is studying the relationship between the attribute in the same table, or the dependency, which attribute depend on the other. Like if you have the primary key, all the other attributes depend in this primary key. If this primary key will be changed, which means that they're going to be changed because it should be unique. You can't have for the two different attributes the same key. So there is a functional dependency between all other attributes and the key in this case. So this is functional dependency. What I mean by here is like here, let's have this table. So you have a table, we name it movie. In this table, you have 6 attributes: title, year, length, genre, studio name, star name. And I said, is this a dependency between title, year, which means that X give Y, this from here, title, year, length, genre, studio name? How I can know this? Let's go here, length, genre, studio name. So when the title and year was 1997 Star Wars, so this is related to this. And when it is changed, this is changed. When this change is changed, and there is a dependency. What about this? Title, year, star name. Star Wars, Carrie Fisher. Star Wars, Mark Hamill. Star Wars, Harrison Ford. I can see there is a here. If there is here, if there is here, a dependency here. So the point that, as we said here, each X value is associated with precise one Y value. To say X give Y. So each X value will have only one value from there. So to say that this is correct, Star Wars and 97 so can be related to Carrie Fisher. Star Wars 97 cannot be related to another one, to say this. Again, to say that X give Y or Y depend on X, each X value, I will say from X value, is associated with precisely one Y value. The same Y value can be related to different X value, but each X is related to only one Y value. Here, this is, I can say, okay, this is, I can say, okay, because title here, yeah, when it is Star Wars 97, it is related to 124 science fiction. I can see another Star Wars 97 related to another rather than 124 science fiction Fox. So this is, we have a functional dependency here. This is X and this is Y. Here, we can't have a functional dependency because X is not related to only one value from Y. Like here, Star Wars is related to Carrie Fisher, Star Wars is related to Mark Hamill. What do you mean star name is one word? Do you have any precise question to ask me? Okay. Why you are describing about functional dependency? Because we need to study the functional dependencies as if we are studying the relationship between the attribute in the same table to see how much they are coherent and to see if this structure is a good structure or it is a bad structure. How I can see it is a good structure? Yes, no. If there is no redundancy, no update anomaly, no deletion anomaly. Redundancy means that I have a huge repetition or a huge null value that I'm using as storage in a bad way. For example, if you have and then null, which means that this is set of value, they don't have any related value for you. You will have, for example, I said you will have here table, you will have here X, Y, Z, W, and then you will have here, for example, you said, okay, if there is a value here, A, B, C, and here null, then null. Whenever this value, always null. Sometimes we have a value, but most of the time you will have a null value for W, which means that W doesn't have always corresponding values with X and Y and Z. In this case, we said, okay, then X, Y, Z, and W, we have a redundancy in the data. It seems that W should be alone, should not be in the same table in this case. So to say it is a good design first, no redundancy. There is no redundant data is being inserted, like null data. Update anomaly and deletion anomalies. And when I say anomaly, which means that sometimes you make an update and you have a missed data. How? We will have maybe example here. Let's take this example. Now we have this example as a database when we have already made the ER diagram and then we make the logic design model or the relational database schema. We have an employee department, employee project, two tables. In the employee department, you have employee name, social security number, base of date, address, and then we'll have a D name, department name, and department GRS SSN, and department number in the same table. At the beginning, if I can see like this, I see it seems that they are not talking about the same concept. Can I have, if this is a foreign key from another table because there is a relationship, it's okay. However, it is not a foreign key and we put two different concepts in the same table, then we will have non-coherent data and then we will have an anomaly in the update. Let's see how. Here we have another one talk about employee and project in the same table. So redundant information in tuples and update anomalies. Information, we said that with storage, we said about redundancy. Now talking anomalies. Let's take example here. Consider this table, employee project, employee number, project, employee name, P name, number of hours. And you want, for example, like here, change the name of the project. You change the name of the project. And here, the value here will be from employee number, let's say employee number 1, and we have employee number 2. And then we have a project number here, let's say also project number 1, and the project number also 1. They both work in the same project. And the employee number here, let's say, take here Nomi. And here you have Kevin. And here we have a project name, let's say project name, it is XY. And here project name XY. And then you go ahead and you change the project name here only, in this. Only in one record. You didn't change in the whole record. However, Nomi and Kevin now, they are working in the same project, but different name being saved. Because when I have already updated, I didn't update the whole record that has the project name XY with a new name. So I will have an update anomaly. However, if I have a good structure for this, like this, having the project here, and then having the employee table as standing alone here. And here having a table concerning about what is the SSN, which is the social security number for the employee, and the project number and hours. So if I have here a one record here, I said here, suppose that P name is XY, P number 11, blah, blah, blah. And then here, I will have the P number 11. And for Numi, let's say the SSN is 00, and Kevin has SSN also 22. And both they work with the project 11 in this table. So if now I change the name here and put it AB, nothing effect, because here the name is not mentioned here, just the number. So I will not have an update anomaly because the data is being now better structured. So any change done, it should be done in a place where there's a coherent data, and I will not have an update anomaly in this case. So it seems that this, all the structure that we have it here, should be break down to have these tables. So to sum up, that if I have a redundancy in the data or anomaly can be from update or delete. In this case, I have to consider restructuring the database. When I said restructuring, decomposing down the tables, it seems that there are some attributes that they are not coherent, they are in the same table. So how I can do this? Perfect. I can do this by studying the functional dependencies and make the normalization based on the functional dependencies. Because functional dependencies will tell me which attributes they depend on each other to keep it with themselves. And the attributes they don't depend on them and they are not foreign key, which is being a foreign key, it is a must to have it because they have a relationship. Not a foreign key, not dependent on this other attribute, go ahead and put it alone on another table in this case. So now we will have more coherence, and so we will have less anomaly and less redundant data in this case. So how to pick the composition? For example, here we can compose in two relation. Now it's better, which means that here you see, put it here, studio name here, I decompose the old tables that we talked about it. So now how I can decompose it? This is a decomposition. We said it is a normalization. We have different level of normalization, which means that go more level will be more more restriction, less anomaly, more restriction, less anomaly by going up in different normalization in this case. So we will have up to 5 normalization in this course. So we will have first normalization, second, third, and BCNF in the third. It is somehow the BCNF. It gives me almost the same result as like the third normalization. However, the criteria is not the same criteria. And then we will have fourth, fifth, and DKNF, which means that going to upper level, you have more restriction, and then you will have more decomposition. But it's depends how much level of normalization you are going to do. In this course, we are going just to talk about the first 3 normalization. First, second, third. For further reading, yeah, you can go ahead and read about the others, but you will be responsible in this course about the 3 first normalization in this case. So normalization means that we have to make a decomposition based on the functional dependencies or other restrictions. We have to consider it to make this decomposition that we are talking about it. More restrictive normal form, that's what I said. So yeah, the least one, it will be very ideal one, but it's not practical because you have a lot of tables in this case. So first normalization, to set that all this table, they are now, I can say they are first. They should, all attributes are atomic, individual. When we talked about before, we said sometimes you will have attribute composite or a multi-value attribute or a composite attribute, if you remember this. which means that we will have different value for the same attribute, like the address. We'll have a composite, or we have a multi-value attribute, like location. You will have different location for the same. So if, like here, location, if we will have this, as we said, doesn't satisfy the first normalization. First normalization said we shouldn't have this, because we believe that if we will have multi-value, then we maybe will have anomalies in the update, that we update in place, doesn't update another one. So in this case, if we will have one of the attribute in this table is multi-value or composite attribute, then we are going to, it is not first normalization. To be a first normalization, we have to decompose it down. How do we decompose it down? Having two tables in this case. Now there is a function dependency, but in the first normalization, we don't consider the function dependency. We consider in the second and the third. So just in the first normalization, to say it is a first department, we can decompose, make a department name, department as sub, and we create a standing alone table for the location. And since a location, this is, and it is somehow, it will be as if it was a weak entity, so it need the primary key from the main table, which is the number of department with the location. Both of them can create the key for the new table. So I double check. I said, okay, it is not a first normalization. I have a multi-value attribute. I got all the multi-value attribute. I created a standing alone table with it. And then I get the primary key for the main attribute table and put it another one as a foreign key to have this relationship between both of them in this case. This is what we said. So now, this is another example about having a multi-value attribute or a composite attribute that P number and P, then also we can break down. Now about second normalization. Second normalization, we have the notation here about fully function dependence. We have the primary attribute, because a primary key can have one attribute or more, and we have non-primary attribute. In any table, we will have always this. We will have the primary key, and primary key can be one attribute or more. And we will have other attributes that are non-primary attribute. So in this case, we will say, okay, to say that we have a second normalization, they all non-primary attributes should be fully function dependent on the primary attribute. What does this mean? Which means that let's take an example, and maybe here is the example here. Yeah. Here, we will have this table. Who's a primary attribute? This is a primary attribute. Who's a non-primary attribute? This. So we have 4 non-primary attributes, and we have 2 primary attributes in this case. So the question will say now, okay, we have 2 primary and we have 4 non-primary. What we are going to see, first, it is first normalization, because if we consider it P location, if not, we are going to create it. If we consider that it is one value, so it is now first normalization. It is second. Let's see. According to the definition of the second, all non-primary attributes should be fully function dependent on the primary attribute. Ours depend, you should have already made the analysis and compute the function dependence. I assume that we have it based on the value as we did before. So we have to search for the dependency based on the value before we go to see if it is a function dependent, it is a second normalization, yes, no. So we have the function dependencies with us. And based on this, we said, okay, ours depend on social security number and project number. So there is a function. This is our first non-primary attribute is function dependent on the other one. What about the E name and the P name and the P location? The E name, it depends in the SSN. And the P name and the P location depend on the P number. This is not fully function dependent. Why? Because all non-primary attributes should depend in the whole primary key, not a part of this primary key in this case. So having ename depend only on SSN, it doesn't depend on SSN and P number, mean that it is not a fully functional dependent. So fully functional dependent mean all non-primary attribute should be fully functional dependent on the primary attribute in the whole attribute of the primary attribute, primary key. So to have it as a second normalization, we are going to break down the non-primary attribute that they doesn't or don't obey the rules. In this case, ename and p number and p location. Ename dependent on SSN, so we put it here as a standing alone table. And now the non-primary attribute fully dependent on the primary key, because primary key has only one attribute now, and this is non-primary dependent on this. And the other one, p name and p location, we do the same and put p number, which means that this is non-primary attribute. They are fully function dependent now. In the primary attribute, we name it p number in this case. So now this is, we decompose this table to 3 tables. This 3 table now satisfy function dependent, second function dependent. I can say that EP1, EP2, EP3 now they are of second normalization. However, are they a third normalization? Let's us discuss this now, if they are a third normalization or not, by telling what is a third normalization. A third normalization talk about transitivity. In the second normalization, we said all non-primary attribute should be fully function dependent on the primary key attributes. By the way, if the primary key has only one attribute, then it will be always second normalization because it has only one attribute. The problem happens when we will have more than one attribute that they will form the primary key. We should be sure to be a second normalization that all non-primary attributes, they are all dependent on all of them, not in part of them. This is the second. The third said it should be second plus should be dependent in the non-primary dependent on the primary directly, not transitively. Example. Here. Here example. Okay, maybe here. So this is about second normalization. Yeah. Now, this is about third normalization. This, we have here this table. We have course, semester, number of a place, teacher ID, teacher name. First, is it the primary attribute is course and semester. All the non-primary attribute depend. What is a non-primary? This one, and this one, and this one. They are non-primary. When I said depend, which means that X give Y, which means that whenever I will have a new value for X, should not be Y, it should be changed in this case. So it can't have two different X the same value, but the Y can be for different X. So now when I have TT01901, this is, I have 100. Do I have the same value again? No. So, okay, if this value, I have 100. If this value, I have 2. If this value, I have 100. This value, I have this. The same scenario here. Okay. Now, The teacher ID dependent all this. Here dependent all this. Here also dependent all of this. So it is second. However, the teacher name also dependent the teacher ID. And the teacher ID dependent on this, so teacher name dependent transitively on the primary key. In this case, doesn't satisfy the third normalization. So the third normalization all should be directly related to the primary key. Should not be there is internal relation or dependency between the non-primary attribute. We can see here that teacher that has a dependency between teacher ID. 332 was Mr. John, and then when it was 332, always Mr. John. When it is 332, Mr. John, and 242 is Miss Smith, and 495 is Miss Bentley, which means that there is a functional dependency between teacher ID and teacher name. So now it is not a third normalization because there is a dependency between the non-primary attribute, which means that they are not directly dependent on the primary key. So to sum up about normalization, first normalization means that has no multi-value attribute. To say it is a first normalization, it is an easy one. If I have it, I should decompose, take this non-multi-value and create it as standing alone table. Second normalization said that whereas a primary key contains multiple attributes, when we will have a multiple, as I said, no non-key attribute, which is non-primary attribute, should be function dependent on a part of the primary key. Should be dependent in the whole primary key. They can depend on a part from it. Third normalization, it is second. If I have to go to see it is a third, it should be first, second. Plus, there will be no transitive dependency of non-primary attribute on primary attribute. When I said non-transitive dependency, which means that the non-primary attribute should not have a dependency between each other. Or dependency, it is one way, from non-primary to primary in this case. This is the whole what I want to discuss today. And time's up for today. So next time I will start with making maybe some exercises about normalization. I will share some examples and exercises before we start with a new material next lecture. And I will send this week your assignment 2. And I will give you a deadline 1 week from sending this assignment. Anyone has any question? I sent. Maybe you don't want to ask any question because you want to leave. This is bad online. I can't see your faces, so I can't know if you really understand or not. We will be back next semester. So Shane, Mason, Nomi, Parnit, Mitesh, Kevin, do you have any question? If no question, I need 4 thumbs up. Shane, the first one. Shane want to leave. Okay, enjoy it, guy. Yeah, see you next week. Have a nice weekend. And prepare well for the other courses midterms. See
Thank you.
Thank
Thank you.
you.
Bye-bye.
I have a